Okay, we're back. Excuse me. So parallel lines and perpendicular lines are pretty much the very last topic that is based on slopes, and it's actually quite interesting if you think about it. Once we started this topic, I spent all this time talking about slope, and I keep forgetting what we are doing is about straight lines. What we are doing is about linear equation. Is about straight line equation. It's just straight line equation can not live without slopes, and seemingly slopes actually took over. I should correct myself more often on that. However, we are going to get to here. Parallel lines obviously are going to be straight lines. So we are going to deal with the straight lines, parallel lines. Hopefully, at least we'll have this idea in mind when we talk about lines that are parallel. Lines that are parallel should always look like this. I don't want to make a mistake, so what I'm gonna do is I'm just gonna copy this. Can I copy this? Okay, let's make it go up or down. So parallel lines should always be something like this, something that will never ever touch each other. So this line can go on forever, but you will never run into each other. And that's really all there is to talk about, the property of parallel lines. Now, the other very important aspect in this chapter that we've mentioned is if two lines are parallel like this, then their slopes, let's say this is the first line, let's call it K1, this is called K2. So the first line is K1, the second line is K2. The slope of K1, M1, the slope of the other one is M2. If they are parallel, then M1 is equal to M2. Okay, if M1 is equal to M2, then they are also parallel. So this comes with two ways. So if, let me write this out, if K1, which is the line K1, parallel, that's how we talk about parallel lines in math, when you have two forward stroke. If K1 parallel to K2, then M1 is equal to M2. Alright. Alternatively, you can also check if two lines are parallel by checking if M1 is equal to M2, then these two lines are parallel. Now, in Algebra 1, this may sound a little bit odd. These two statements, it seems, similar, but actually it has a different purpose. It serves a different purpose. If you are in my geometry class, possibly you've seen it before. Okay, it's one of those converse statements. So one of them is actually proven the property of the lines. Okay, the other one you actually use the property of the line for the slope. So, but as far as this chapter concerns, we need to know that if two lines are parallel, they are going to be having the same slope. All right, if m is equal to 7. Then M2 has to be equal to 7 as well. So parallel lines and slopes are very simple in that the checking itself is not too difficult, so we are moving right on. Perpendicular line actually is not too bad. How perpendicular line looks like would be something like this. You have two lines going two different ways. Hopefully it's going to form a perpendicular lines. When they say it's perpendicular lines, it has to have this format. It's going to be a 90 degree in between, so that is going to be 90 degrees. Alright, and so we are going to say this is K1, this is K2 again. So K1 and K2 are perpendicular. We normally will write it like this. K1 is like an upside down T, that means perpendicular. K2. Okay, so when we were doing this in class, I will actually introduce this idea for negative reciprocal. Negative reciprocal. Let's write this out. Can I type this out? So this idea, I do want to go over that first because I noticed that a lot of you are still having some issues with that. So can I move those as well? Good. So what does it mean by negative reciprocal? If two lines are perpendicular to each other, then their slope, m1 and m2, will be reciprocal to each other. So if k1 is perpendicular to k2, then m1 is negative reciprocal of m2. So these two numbers, they have this nice property called negative reciprocal. So let's just tell you what negative reciprocal means. Negative reciprocal, there are two operations over here. The first one is putting the negative in front of the number. Reciprocal basically meaning you are flipping the fraction upside down. Okay, you change the numerator and denominator of your fraction. Okay, so let's say I will just start with a fraction. Fraction is much easier to understand in this scenario. So let's say as an example, 1. If I know one of the slope is 3 over 4, then the negative reciprocal of this is negative 4 over 3. You put the negative in front of your original slope, and then you flip this number. Okay, reciprocal is flipping the number. Example 2. So let's say I started off with a negative 1 over 2. Negative reciprocal of this is going to be 2 over 1, or simply put, it's just 2. Okay? Then example 3. If your slope started off with just an integer like 7, your negative reciprocal is negative 1 over 7. Now the reason for that is, if I have only 7 on its own, basically this is 7 over 1. I can always do that. And then after the negative reciprocal, you're going to get negative 1 over 7. So that's the nice property of this. If I am giving two of those slopes to you, you will be able to tell me if they're negative reciprocal of each other. If they are, then they are perpendicular. So that 90 degrees is going to be there. Okay, so that is the basic concept. If two lines are parallel, then they have the same slope. If two lines are perpendicular to each other, then we have to apply something called negative reciprocal to it. That's basically the two really important ideas as we move forward from this slide. So I want to talk about a few questions, or maybe just this whole lot, because I've graded that paper and it's not perfect, I would say. Okay, I think some of you were not really confident about whether it's true or false, and let's just spend the time and just go over this whole bunch of true or false. The line y is equal to 4x minus 8 is parallel to the line y is equal to 4x plus 2. Is it true or false? So we have to think about, okay, they're parallel. That means the slope has to be the same. So we look at our equation, and thankfully this is in slope-intercept form. So my slope has to be 4 for the first equation. The slope is going to be 4 for the second equation. So the answer is true. Alright, so they have the same slope, therefore they are going to be parallel. Second question, the line y equals 2x minus 12 is parallel. So again, they are looking for the same slope. 2 and 2, they sound very much the same to me. True. Next one, the line y is equal to 3x plus 23 is perpendicular to the line. So this one is about perpendicular, so we have to talk about negative reciprocal. So I'm going to start with 3. Okay, so negative reciprocal of 3 is going to be negative 1/3. Look over here. Do I have negative 1/3? No. False. Next one, the line y is equal to 2/3 x minus 6 is perpendicular to the line -3/2. If you still cannot see it, let's just weigh it out. 2/3, negative reciprocal, -3/2. There you go. They're true. Okay, the line y is equal to 12 is parallel to the line equal to 1. Now this one is a little bit more difficult. Okay, we didn't have the mx, right? We are looking for the mx. And if you watch one of the videos before, I would actually talk about it. Y is equal to 12, same as y is equal to 1. The mx is not there. That means the m in this scenario is just going to be 0. And the same applies over here. It's not there. That means it's 0. So 0 is actually equal to 0. Therefore, it's true. A lot of you put false for this. Okay, the line x is equal to 3 is perpendicular to the line x is equal to 5. So this one is even more difficult. And I think I showed you how I would do it in class today. And I said I would normally just draw it. And I said x is equal to 3. No matter where you are, x is going to be 3. No matter where you are, x is going to be 5. That means it doesn't matter where you are. This is going to be a vertical line. It doesn't matter where you are. This is a vertical line. So basically they're saying that these two vertical lines perpendicular to each other? Of course not. They are parallel. If they ask you if it's parallel, then yes. So in this scenario, they are actually parallel. So false. Alright, false. So these sets of questions, I think the last couple of them, people have problems with them. So I just want to get this out of the way. Okay. Then it gets to the very last bit. It's really the last bit of this. I do not want to do all of them. I will do one parallel, I will do one perpendicular. Okay. So the question is not going to change too much. I'm just going to do this first. Just going to do this first. And then we're going to have a new one. Oh no, cancel. I'm going to do a new one. So this is the first one. And then I also want to do another one right over here. New. Let's just cut this. It's about perpendicular. So in 2 questions, we are done. I'm so excited. Now I'm going to start on the topic. Pretty sure about that. Alright. So things like this, well, they will say point slope form, and I'll tell you why. They're saying that we want to find a line that is parallel to y is equal to 5x plus 12, which contains the point 5x. Okay, so what this question actually is telling you, or asking you, asking you to do this. I have my x or y axis over here. I have a line which is like this. Let's use red. The y-intercept is going to be 12, so it's 12 over here. And it's a positive slope. I'm drawing it very randomly. Okay, so this is my line. Y is equal to 5x plus 12. Does that have to be perfect? Oh my god, can I erase that? I really hate using the mouse writing this. My handwriting normally is much better than this, seriously. So this is the red line. I have this y is equal to 5x plus 12. This is the line that was given to us. We want to find another line, okay? Write an equation in point slope form that fits the description given. That means I want to find another line that is covering 5x. Okay, 5x, I do not know where that is. So I'm just going to say 5x because that's 12. So let's assume it's somewhere over here, 5x. So this is my 5x. Okay. I want to find another line, which is green, that is containing the 5 and x, going that way, and they're parallel to each other. Alright, so we know the red line already. I'm not doing the red line, I'm doing the green line. So you have to understand what kind of information you are being given in order to solve this. So why do we want point slope form, you may say? The reason for that is I have a point. This green line is definitely getting through this 5x. So my first point on my point for the point slope form is 5x. And then because they are parallel, therefore my green line, I know that it has to be equal to just 5. Alright? The rest of that is history because I know my point slope form by now, so it's going to be wait again. So 5 is equal to y minus x minus 5, and then do the cross multiply at the end, y minus x 5 times x minus 5. Alright? So if it's parallel, it's really not too difficult. You know that two lines are going to be parallel. You pick up the slope, m is equal to 5. Alright? Normally you do not have to draw that diagram, and I will encourage you not to because it takes a lot of time. Aren't you glad this video is about 16 minutes already? So this one, we have 6,1. So my point is 6,1. This time it's going to be perpendicular to it. So I have to figure out what that means. Perpendicular means negative reciprocal. When you see this, the negative reciprocal is going to be your go-to, okay? So I'm going to pick up this 3, do a negative reciprocal to it. So my m is going to be negative 1/3. Alright, then negative 1/3, and that point is going to serve whatever we want with them. So point slope form again. Oops. Oh. I should avoid writing too fast because I keep making that mistake. So point slope form, slope negative 1/3 y minus 1 x minus 6 cross multiply 3 y minus 1, that negative 1, let's just multiply it out, just be nice. So 3 y minus 1, multiply that, you have negative 6 plus negative x plus 6, make it even nicer looking. There you go. So we are done. As I said, if you've been following up to this point, they keep asking the few simple idea is either slope-intercept form or point slope form, and then they will basically give you a different bunch of scenario or information. So you pick your proper one. This one is ideal with the point slope form because they always ask you, I'm going through another point, so I'm going to give you either a parallel line or perpendicular lines. That's how you get your slope. And then point slope form it, you are going to get your result. Alright, I know this video is a little bit longer because this is, I would say the most difficult concept in this chapter. Other than, the one that you have to find the equation with 2 points, that one was just a lot of steps. This one is more about the concept. Do you understand that picture that I draw earlier? Okay, that's what they are asking you to do. Alright, and that's pretty much it for the slope. That pretty much cover everything, and if I feel like it, I will do another one. Possibly tomorrow I'll cover the special case which some of you had problems with, but if you are preparing for your test, I would highly encourage you to watch all of these videos, and bye for now.